Hi, thanks for joining me today. I'm going to be doing another irrationality sort of theorem. We want to know, is pi plus root 2 rational? Okay, so we know that pi is irrational and that root 2 is irrational. I've made videos for both of these, links in the description below. But we want to know, if we sum these two together, can we get a rational number? Let's get stuck into the proof. Okay, so before we get stuck into the proof, I want to talk quickly about transcendental numbers and what they are. So we have the set of all numbers, which we're going to just think of as a set of complex numbers, and then a subset of those complex numbers are numbers which we're going to call transcendental. Okay, and transcendental numbers are basically just numbers which can't be written as the solution to a polynomial with rational coefficients. So it's probably easier just to give you an example of a number that's not transcendental, and those are called algebraic numbers. So root 2 is certainly an algebraic number, it's not transcendental. Why is that? Well, root 2 is a solution to x squared minus 2 equals 0, oopsie daisy, and this is a polynomial. The left hand side is a polynomial with rational coefficients, because you just got a 1 there and a minus 2 there, so everything's rational. I, the square root of minus 1, is also an algebraic number, even though it's complex, but we can write it as a solution to x squared plus 1 equals 0. So I is also an algebraic number. Now, transcendental numbers, or proving that a number is transcendental, i.e. not algebraic, i.e. not a solution to any polynomial with rational coefficients, is very, very difficult. So I'm not going to try and prove that any numbers are transcendental in this video, but I'm going to use the fact that pi is transcendental. So that means that pi cannot be expressed as a solution to any polynomial with rational coefficients, and that's kind of the key to the proof. Another famous transcendental number is e. E is also transcendental. Anyway, hopefully I've given you a brief explanation as to what transcendental numbers are and algebraic numbers are. Numberphile have made a really good video kind of explaining, so I'll leave a link to that in the description below if you want to check that out and kind of get a better understanding of what they are. But all I'm going to be using in this video is that pi is transcendental. Let me clean this up and we'll get stuck into the proof. Okay, so in fact, pi plus root 2 is irrational, and the way we're going to prove that is the way you prove most sort of irrationality arguments, is by contradiction. So let's suppose for contradiction that pi plus root 2 is indeed rational. So let's write pi plus root 2 equals q for some rational number q. So q is in the set fancy looking q. Okay, now what we're going to do is just take this and square both sides. So the left hand side just becomes pi squared plus 2 root 2 pi plus root 2 squared, which is 2, and that equals q squared, like so. Now there's root 2 here. We can use this sort of line to write root 2 as q minus pi and just plug that into here. So this becomes pi squared plus 2, root 2 is then q minus pi, times pi, then plus 2, and that equals q squared. Now when we expand this guy out, we're going to get a 2q pi and then a minus 2 pi squared. Pi squared minus 2 pi squared is minus pi squared. And then we get a plus 2q pi plus, and then I'll bring this q squared onto this side, so it's 2 minus q squared equals 0. Okay, and have a look at this guy here and see if you can see what issue there is with this line here. Okay, let me go over what the issue is here. Well, this contradicts the fact that pi is transcendental. Why? Well, because if we consider this polynomial here, p of x equals minus x squared plus 2qx plus 2 minus q squared, clearly this guy has all rational coefficients because minus 1 is rational, 2q is rational because q is rational, and q squared is rational because q is rational, so 2 minus q squared is certainly rational. So it's a polynomial with rational coefficients, but we're claiming that when we plug in pi, we get 0, but then that contradicts the fact that pi is transcendental. And thus we arrive at our conclusion, and therefore this guy here is irrational. It cannot be rational. So yeah, I hope you have enjoyed this short proof using the fact that pi is transcendental. I would leave as sort of a belated April Fool's joke to you to try and use this to prove that pi plus e is also irrational. But in fact, knowing whether this is irrational or not, nobody knows. We don't know yet if this guy here is irrational or rational. We can't use this argument. So I guess not April Fools. I mean, it's the 3rd of April today. But yeah, anyway, hope you have enjoyed this video. Thanks for watching. As always, I'll catch you in the next one. Have a great day.